In this video, we'll be going over the Unit 2 review packet, and we're going to start with Topic 4. Question number 1, circle the hypothesis and label it P, and box the conclusion and label it Q. When you have a conditional statement, the hypothesis is always the part that goes with if, and the conclusion is always the part that goes with then. So my hypothesis would be two lines intersect to form a right angle. That's the part that goes with if, so we'll label that P. And the conclusion goes with then. They are perpendicular. That's going to be my Q. Notice how the words if and then are not a part of the hypothesis and conclusion. We don't circle them because they're actually a part of the conditional statement. Number 2. Draw a Venn diagram for the conditional statement in number 1. In a conditional statement, the hypothesis always goes on the inside of the Venn diagram, and the conclusion goes on the outside of the first circle but inside the second. So if we were to draw two circles, one of them to represent the hypothesis and one of them to represent the conclusion, my hypothesis, two lines intersect to form a right angle, is the one that goes on the inside. And my conclusion, they are perpendicular, goes on the outside. The reason we do this is anytime two lines intersect to form a right angle, they will automatically be perpendicular. However, anytime two things are perpendicular does not mean that it was two lines intersecting to form a right angle. Essentially, if this happens, then you're absolutely certain the outer part will happen. However, it doesn't work the other way around. Just because the then part happens doesn't mean the if part is what caused it. Number 3, write a conditional statement for the Venn diagram. Well, using what we know here, we know the hypothesis goes on the inside, the conclusion goes on the outside. So here my hypothesis would be wheat, my conclusion would be grain. If wheat, then grain. If it is wheat, then it is grain. Write the different forms of the following conditional statement in symbols and words. If I ride the Ferris wheel, then I am not afraid of heights. If P, then Q. Now be aware that the order that you see these may change. It may not always be converse, inverse, and contrapositive, like you saw in the quiz, where the order was changed as well. The converse is what you get when you switch the hypothesis and conclusion. So instead of P to Q, we have Q to P. In my original statement, I ride on the Ferris wheel is the hypothesis. Highlight that in yellow. And I am not afraid of heights is my conclusion. Highlight that in blue. And we'll label these P and Q. If I were to switch these around, if Q then P would become if I am not afraid of heights, then I ride on the Ferris wheel. Inverse is what we get when we take our original conditional statement and negate it. Not P and not Q. P was I ride on the Ferris wheel, so the negation of that would be if I don't ride on the Ferris wheel. Then, here our statement is, I am not afraid of heights. Well, if you negate this, you would get, I am not afraid of heights. But just like in mathematics with logic, when you have a double negative, it becomes a positive. So this would become, then I am afraid of heights. Finally, the contrapositive. The contrapositive is the result of doing both of these things, negating the statements and switching them around. So our symbols are going to be not Q, not P, and then I'm just going to take my inverse, those statements not P and not Q, and switch them around. So we would have if I am afraid of heights, then I don't ride on the Ferris wheel. Question 7. 15-year-olds can get their driver's permit. Show this symbolically and explain why you chose the symbols that you chose. Well, if this were a conditional statement, we'd have two parts, our hypothesis and conclusion. The hypothesis would be 15-year-olds, or if you are 15 years old, and our conclusion would be then you can get your driver's permit. If you are 15 years old, then you can get your driver's permit. It says show this symbolically and explain why you chose the symbols that you chose. Well, symbolically, this would go P to Q. If you are 15 years old, then you can get your driver's permit. So my symbols would be P to Q, and for my explanation, I'm going to write if you are 15 years old, then you can get your driver's permit. And the reason I chose P to Q is because this is a conditional statement, and P arrow Q is the symbols for that. Use P and Q to write the following symbolic statements in words. P points X, Y, and Z are not collinear. Q points X, Y, and Z are coplanar. This says not Q. So Q points X, Y, and Z are coplanar. Not Q would be points X, Y, and Z are not coplanar. Number 9, the symbol in the middle is and this is the negation. So this says Q and not P. Just like the substitution property of equality, wherever I see one of these letters, I'm just going to plug in the words for whatever that was. So this says Q, so the first thing I'm going to write is points X, Y, and Z are coplanar. Next, we have the symbol and, so I'll write the word and then we have to write the negation of P. Well, P is points X, Y, and Z are not coplanar. If I negate that, it would be points X, Y, and Z are not collinear, aka points X, Y, and Z are collinear. Number 10, if not P, then not Q. The arrow in the middle means we have an if-then statement, and now I have to negate both of them. Now I already know the negation of Q and the negation of P because I had to do it here and here. So not P was points X, Y, and Z are collinear. So we will say if points X, Y, and Z are collinear, then now I need the negation of Q. Points X, Y, and Z are not coplanar. Number 11. Fill in the blank with the correct response. If a conditional statement is true, then the blank is also true. If a converse statement is false, then the blank is also false. Questions 11 and 12 are both related, and they're talking about equivalent statements or truth buddies. Each statement has another statement that it is always either true with or false with. They always hold the same truth value. For the conditional, its truth buddy is the contrapositive. For the converse, its truth buddy is the inverse. Rewrite the following conditional as a biconditional statement, then determine if it is true. Like most of these questions, the first thing I'm going to do is highlight my hypothesis and conclusion. Here the hypothesis is two segments are congruent. The conclusion is they have the same measure. To write a statement as a biconditional, instead of writing if P, then Q, we write P if and only if Q. Here, that just means I'm taking my hypothesis, two segments are congruent, place the words if and only if next, if and only if, and then put my conclusion. They have the same measure. The symbol we use for a biconditional is a double-headed arrow. So we would do P, double-headed arrow, Q. Finally, it says, is this biconditional a true statement? In order to be a true biconditional, your statement has to be true both ways. So if two segments are congruent, then they have the same measure. Yes, that's true. If two segments are congruent, they will have the same measure because that's what it means to be congruent. Now we flip it around and check to see if it's true the other way. If two segments have the same measure, then they are congruent. That's also true. If two segments have the same measure, then they are congruent. Because this statement worked both ways, it is a true biconditional.